What is so special about two old Schindler lifts from 1968? I have a few words for that. Mechanical, interesting, fascinating, I'd even go as far as epic. Because just wait until you see the machinery that used to control these lifts before microprocessors were around. I think we'd better go back up to the motor room to continue the tour that started in part 1. And who do we have on the other end?
Harry.
Mr. Harry Healy 02. This is part 2. There are some bits and pieces to examine here. The floor selector and of course the all relay control cabinet. Okay, so we have really 3 parts of this. We've got the switches in the middle. They remember the car's floor position for direction purposes. I've done quite a few videos about the logic of that. Basically, these switches have 2 positions. They're either sort of like in or out. Perhaps when it goes around, we'll have a closer look at that. Here we go. Where is it? Okay, let's film that cog first, if we can. You can see that cog in there. There's the cog that turns it around. Here are the switches. That's going to move it one way or the other. There you go, let's fix it back out. Have a closer look at that cog. And then this. Let's look that up on the cabinet. U1. Maybe U is floor. For that, the notches seem to represent the actual floor position. But the thing is, you notice that that roller floats for a little bit before it stops. So I'm not sure if this is the exact stopping position or whether something else does that. Okay, so this bit here.
There's one just at the back.
Was there?
Yeah. See right down there.
Oh yeah, I didn't see that one before.
Looks like it's touching.
Oh yeah, it's down there. Okay, so this bit here is for the floor indicators. And this is quite interesting because we have a common wire in the middle there. Then we have 1, 2 other positions. This is all this has is 2 floors.
Yeah, it's only got 2 floors.
Oh right, okay.
The other one over there is 4, but you can only get to 2 of them.
Okay, I see. So on the other one over there, we should see more wires attached to it. But the way this works is the copper contacts from there that go around the edge. That represents 1 position, so that could be like the ground floor. And then when the selector on the other side goes past this point, the lamps go out, and then it joins in with this next set of contacts for the next floor. And you see the linkages, that just keeps the lamp on as it goes around, and then it only goes off when it goes on to the next floor. So if we have a look at the other side, you will see that there are 2 separate rings, an upper ring and a lower ring, and what it does is it connects the outside to the inside, and those pins, so we're going to get some action here, create a circuit. So the circuit goes from the outside ring to the pins in the middle. Here we go. We've got an inner set and an outer set. So that's right down the other side there, so that will be joining the tracks on this side. So whatever that floor is, it's in this region here.
To see how this works in far more detail with one of my animations, I am creating a new Schindler wheel floor selector video. There is also a separate video that explains how the direction logic works from the inside roller switches. See the link at the end of the video.
Be interesting to see that one over there. So if we have a look at the connections at the top there, these are the connections from the cabinet to the actual floor selector. So this whole wheel would have been manufactured probably in a workshop somewhere, and then the engineers then connect into this. And then you've got to set it up. You've got to move these around a little bit so you can see the nut there that you loosen it to move this in and out.
It would have been a lot of trial and error, do you think, to get it perfect?
Absolutely, but they probably have particular ways of doing these, and probably the more experienced engineers and have got some kind of technique. You put it in a certain place and you run it, I don't know. But nowadays, my goodness, setting one of these up, I don't think you've really got the knowledge to do it. So that's the floor selector. Then we come to the cabinet. Alright, so these big resistors are for lots of different purposes. And without a diagram, it's very difficult to work out what they do. They can be for timing circuits. They can be used for the motor. Over here, what do we have here? Primary and secondary, they're transformers. So converting one voltage to another voltage. Let's have a look, see if we can see what voltages it does. Maybe take that away. No, I can't quite see that. So transformers. So above it is a circuit board, and that is yeah, it's a 12-volt power supply. So that's normally doing the alarm bell, and there's normally a battery attached, which if the system loses power and you get stuck in the lift and there's no power, you can press the alarm button and then this will ring the alarm bell. But where is the battery? Have you seen the battery yet?
No, I haven't.
I have. It's there. That is the battery. wonder what.
Very long, isn't it?
Well, it's only there for just to ring the alarm bell, I suppose. But I wonder what date's on that. I wonder how old that battery is and whether it's been replaced recently. Because these, if they're being charged up, only last between about 3 and 5 years. So there's a battery, and that looks like it's been there for a long time.
Like it's been there since that thing was put in.
Okay, so these are old-fashioned fuses. Okay, so this is all the relay logic. More fuses. There's a rectifier there. The hell does that do? Looks like a reed switch or some kind of. Oh, I know what that is. I know what that is. That is a. And when that component in the middle gets hot, then that bit of metal, bimetallic strip, that's it. Then that middle bit will bend and it will activate a switch, and that will obviously cut the supply off or shut the lift down. So it's some kind of overload. When that gets hot, it cuts the circuit off. Okay, up here, more resistors. Now I think that these are more for timing circuits, these little resistors up here. There will be a capacitor somewhere, and then this will control how much power goes into the capacitor. See any capacitors? No. URS, maybe we can look that up. Right, now this.
Wait, is that a capacitor up there?
It is. I'm coming up that way. What is this? I've seen this before. That's a switch. This looks like a motor. So it would appear that this motor does not turn very much. It's just a little tiny bit in there. And when it does turn, it activates that switch. Although perhaps it releases the switch, because it looks like this part can come upwards, and then it will release that switch.
You can kind of see through it actually, it's a bit of plastic glass.
Oh yes.
careful.
Yeah, I'm watching these contactors. Yeah, so there is a switch, and it's activated by the top, like little flipper, but it seems to be some kind of motor. So why would you need a motor to activate a switch? Must be a reason for that, but that is a mystery. Okay, and then up here and over here we have these are for slow speed, high speed, and there's probably a main relay in there as well. But if you look at all of the labels, they are all, well, not really identifiable. First, second, third. This is not going to be the floors, this is going to be the stages. So first stage, second stage, third stage. Third stage. Up here we have the door open. Oh look, door close, front basement door open, back door close, back door open. Okay, then up here, what's this? Flat Schindler lifts.
Is that the door open time?
Could be. It says on there actually, parking delay. So it would appear that this relay, or this timer, activates the return to a parking floor maybe, if it was set up. Up here we have some timers, very old-fashioned timers. And then there's the capacitor that you were talking about, and to be honest, I don't know. There is a capacitor, but I think it's part of whatever that board is. Brake relay. Up relay and down relay. Okay, moving backwards now. Okay, should we put it back on? Was it? Well, we have a, oh look, it's got some markings on it as well. It seems to have more positions on it, so that's one position. Why would you need two separate rings to go around? So that is the first floor, that's the ground floor, and that's the basement. And this could just be spare, so if I look at the other side, yep, that's what makes the circuit. Key switch, that's quite interesting. So you turn the key and it looks like it mechanically moves that. Okay, the buttons are quite interesting because we have two sets of contacts. We have a set of contacts here, from there to there. What have we got in here? Oh, look at that.
Yeah.
Car coming indicator lamp with a button that goes through it.
Cool, this dates
My
back to
goodness me,
85.
what the hell? Oh, I see, this is one of the rows of relays. It looks as though they had some kind of building work done. I mean, these don't look in very good condition. What's that, water damage? Maybe there was a leak. Old relays. another set down there as well, but this gives us an opportunity to have a look at the relays. So we have 1, 2, 3, 4 normally open switches. The relay activates, they join together, and in the middle is a normally closed switch, so that one actually opens when you activate the relay. The relay is activated by the electromagnet behind.
Yeah.
Contractors on site, and then, was that about a month later?
Yeah.
Ugh, what a mess.
Till 1989.
Oh yeah.
But then obviously they've got probably more recent.
Yep.
This one's even older.
Same handwriting.
84.
Builder's rubber. Builder's rubble over governor built.
Overrun, that's not good.
This looks like, I thought it was just lines on there, but it's not, because if you shine your torch through, go a bit closer to the wall, they're actually slots. Okay, let's go down to where they get close together. There we go. Now, is this used for the lift here, the old one, or is this some kind of optical device? I don't see how an old lift can sort of like read this. Yeah. I mean, it's not sort of like binary or zeros and ones, but I know it's not binary, but the closer the pulses become together is where the stopping position is until it gets to there. Interesting. May not be for this lift, but let's put it back up there.
What's that? Oh, is that the
Lift door key.
Hmm.
Just the pole. 2 different motors with 1 shaft.
Yeah, because inside you can see
The windings.
Yeah.
So you can see the windings down there. So I think the answer to your question is, why is the motor so long? Is because, well, you just pointed out yourself. I think it's actually 2 motors. One of these is possibly for low speed, or one for high speed. On other motors, they might put the windings sort of like together, but, well, it seems Schindler have 2 separate windings, and that is confirmed by these junction boxes.
And also, in the British Library, they've got one of these right in this right here. This one doesn't exist.
All right.
Same size.
Yeah, very interesting.
In a moment, some answers to what some of these devices are, but first, this motor. Why is there a motor in the cabinet? Why is it not turning? And why do we even need a motor in the cabinet in the first place? What is it going to turn? To find out, please see a separate video dedicated to why we need this motor in the cabinet. There is a link at the end of the video. What's this optical device? And why does the roller switch float for a second after it's deactivated? It appears that the roller switch is only a part of the stopping action. There appears to be an additional device on top of the lift car which could have something to do with this alignment or testing aid. But without seeing on top of the lift car, we cannot see for certain what this is for. Please comment if you are a lift engineer and have some ideas. Now the additional roller switches in the middle of the Schindler Floor Selector wheel. This inner set are probably over travel switches. The lift only stops at 2 levels, so it's not possible for the selector to reach this switch unless the lift over travels. This would be a backup to the roller switches placed at the top and the bottom of the shaft, which also shut down the lift in the event that the lift goes too high or low. Bottle fuses. Apparently these were not a popular design. They look like resettable circuit breakers, but they are not. The fuse wire is attached into a cap, then screwed into the fuse holder backplate in the cabinet. Here is another Schindler lift with bottle fuses, but this time the fuse cap has been unscrewed and you can see inside the holder. Inside the cap, the fuse wire keeps this plastic indicator pressed against the front, so you can see if it has blown or not. Should the fuse blow, the plastic indicator cap is released and would ping into the fuse cap and would have to be placed back into position before the fuse wire is replaced. In part 3, it's all action. You will see the best bits of different combinations of all my cameras filming together. It's the multi-camera views where the action doesn't stop. Until we decided to go home, that is. Don't forget to see the motor inside the cabinet video by clicking it here in the top right. I take a lot of time and effort to bring you quality, interesting videos. I'm all about quality, not quantity. I hope you enjoyed watching this video. If so, then please consider subscribing to the Mr. Matt and Mr. Chay channel. And also visit the Harry Healy 02 channel by clicking the video in the bottom left. Without Harry, this video would not be here today.